So in the previous video, we discussed about vector database. That was the foundation we need to discuss about RAG or Retrieval Augmented Generation. So in this video, we'll discuss about RAG in depth. So stick around and let's get started. RAG is Retrieval Augmented Generation. So first, let's see why we need RAG. So there are few limitations of LLMs. So traditional LLMs are trained on vast data sets, right? But they don't have access to real time or external knowledge after their training. So this means they can give outdated or inaccurate answers, especially when the information they need is not within their training data. So suppose if you are dealing with some of your own company specific, organization specific documents, right? And you have to extract informations out of that, right? You want to ask questions and get answers from those documents. So the LLM, traditional LLM won't be able to answer that, right? Because they don't know about this data. So here comes RAG. RAG, what it does, it integrates a vector database with the LLM. What it does, it allows AI to pull up-to-date external information in real time, ensuring responses are more accurate and relevant. So that's because we are using an external vector database where we can store our own data, and with the LLM, with the help of LLM, will be generating the response. And in this way, we'll be able to get the up-to-date, the external information that we want to work on. So what it does basically, retrieves data from external sources. Unlike traditional AI models, RAG can pull in relevant information from external database or documents before generating responses. It enhances the LLMs. So it uses large language models like GPT to generate the response, but with the added benefit of real-time information retrieval. So it uses the LLM to generate the responses because large language models understands the language, the patterns and all, right? So it will be able to generate the response properly in a normal, in natural human language. But it to get the information, like the large language model doesn't have context about your own data, right? So to get the context, we'll use some external database. So it's in one way, it's enhancing the LLMs for your own purpose. So we can see RAG in different ways. If you can say LLM plus vector database is RAG, of course it's like RAG is LLM plus vector database only. And also we can see it as a two phase, where first is information retrieval and then the text generation. So this is RAG, right? Information retrieval from the vector database and text generation using the LLM. So that is RAG. So there are two steps for this whole pipeline. First, we have to load and store the data we want to work on, right? So if we have our few external documents that we want to work on, so we have to load the data, and the next step is after loading the data, we can ask the RAG that questions from that stored data, and it will be able to answer that. So that is the retrieval phase. So first phase is loading and storing the data. Loading and storing the data can be also divided into three steps. First, you have to load the data. It can be any type of documents, like starting from text documents, PDF, or some data or websites. Like if you want to get data from a web link, right, we can load the data. So if we are using the LangChain framework, there are different types of loaders available, so that using that we can easily load different types of data. Then we split the data. We break large document into smaller chunks. Why do we do that? This is useful for indexing data and for passing it into a model, since large chunks are harder to search over and won't fit in a model's finite context window. So there are reasons why we break a large documents into smaller chunks. So what first of all, what is a context window of a model, of a large language model? So when we saw in one of our previous video, there when we are discussing about language model, so we saw like when we want to generate one word, we are seeing previously whatever word we already have generated, right? So and but this we are just seeing in a finite window. This window is not infinite, right? So so if we are feeding a large document that doesn't fit in that context window, then LLM will not be answered from that, right? So and that's why we just break large documents into smaller chunks. And one more reason is large chunks are harder to search over as well, because when you will be storing the chunks into the vector database, of course the embedding of the vector database, so if we store smaller chunks, it's easier to find the relevant chunks from the vector database. After splitting, we need to store it, and we need somewhere to store and index our splits, right? So vector database, in the vector database we'll be storing the embeddings of these chunks, right? And we need to index the data so that we can easily search over this embeddings, right? So we need somewhere to store and index our splits, so that there the vector database comes into picture, right? So these are three steps: load, split and store, for loading and storing the data. After that comes the retrieval and generation phase. Retrieval is like when we want to ask something from the data. Given a user query, generate its embedding and retrieve a similar vector embedding from the vector database. So when we want to ask some question from the data we have stored, we can give the query, will generate the embedding, will get the similar embeddings from the vector database. That is a retrieval phase. Next is generate phase. Generate phase is when the chat model LLM will actually produce some output. How it does is, will create a prompt with the query and the similar embeddings that we have retrieved from the vector database, and will pass both to the LLM. And LLM can generate some response, because it knows about the human language, right? It can generate some useful answer, uh, useful answer from that retrieved data. So that is two phase when retrieval and generation. So here I am just showing it in picture. So suppose if you are dealing with a few PDF documents, first we'll load the document, and then we'll split the documents in different chunks. Then for each chunks we'll create embeddings, and in this embeddings will be stored in some vector database. Next, when some query is coming, so this query will create the embedding for that query as well, and will retrieve few similar vectors from the vector database. After we retrieve few similar vectors, then we'll create a prompt that will contain the query and the retrieved similar vector from the database, and will pass that to the LLM. So LLM will have the context now, and now it will generate some answer. So this is the whole flow of RAG. So in our next videos, we'll actually try to implement it with few different vector database like ChromaDB and Pinecone.